Hi everyone, welcome to our Math 70 video lecture. We are into chapter 6. This is section 6.1, solving quadratic equations using factoring. So what is a quadratic equation? Well, it's just a quadratic expression that equals something. X squared plus 5x plus 6 equals 0. And if I want to solve this, I'm going to find all x values, then make the equation true. And in this case, that's find the x values that make the quadratic equal 0. So I want to motivate this using Desmos. Suppose I want to solve the equation. Let me put this as a note. Solve x squared plus 5x plus 6 equals 0. So let's take a look at that quadratic expression, the x squared plus 5x plus 6. Solve that equation equals 0. That means we want this value or this function to equal 0. And if I zoom in, I can see two places. Nope. What x values make the output 0? Well, the output's 0 when I'm on the x-axis. So what x values make the output 0 is what x values make the graph touch the x-axis. And we have a word for those x values. What are the x-intercepts? So solving x squared plus 5x equals 0 is asking what are the x-intercepts of the expression x squared plus 5x plus 6. Now Desmos, we can see right there, aha, those x values are -3 and -2. So the solutions are x equals -3 and x equals -2. The x-intercepts are -3 and -2. Those are the x values that make the graph touch the x-axis, which are the x values that make the output 0, which are the x values that make this initial equation true. And now what I want you to notice is that if I factor x squared plus 5x plus 6, I get x plus 3 times x plus 2. And right there, hidden inside my factors, are those exact solutions. X plus 3 corresponds to x equals -3, and x plus 2 corresponds to x equals -2. So let's do another example on Desmos, and I'll switch back to my notepad. So delete all this. And let's solve. How about x squared minus 4x minus 21 equals 0? All right, so I want to find the x values that make the equation true, which is finding the x values that make the quadratic expression equal 0, which is finding the x values that make the graph, let me go one more step, finding the x values that make the graph touch the x-axis, which is find the x-intercepts. And so let's do it. Let's find the x-intercepts using the graph x squared minus 4x minus 21. There's my quadratic function, and there's an x-intercept at -3, and there's an x-intercept at 7. And of course, if I were to factor, I would get x plus 3 times x minus 7, the exact same graph. So that means the x plus 3 corresponds to x equals -3, and x minus 7 corresponds to x equals 7, and those are my solutions, x equals -3 and x equals 7. So by factoring my quadratic equation, I can find out the solutions to my original. Let me say it again. By factoring the quadratic expression, I can find out the solutions to my original quadratic equation. All right, let's do that again by hand for each of these without Desmos to help us. So we solve, make sure I'm sharing. Yep. We're going to solve x squared plus 5x plus 6 equals 0. And to do that, we're going to find the x-intercepts. To find the x-intercepts of the expression, we do it by factoring. I'm going to use the box method just to remind you, but often I'm going to skip the factoring part of these examples. And you can practice that on your own. X squared and 6. So two numbers that multiply to be 6. They could be positive numbers or negative numbers, but importantly, they have to add to 5. There we go. 2 plus 3 equals 5. So I have a 2x and a 3x. So it's x plus 2 and x plus 3. So x squared plus 5x plus 6 equals 0 is the exact same equation as x plus 2 times x plus 3 equals 0. And notice if I put -2 in for x, I get 0 times 1, which is 0. That works. And the same thing if I put -3 in for x. I get -3 plus 2 times -3 plus 3, which is -1 times 0, which is also 0. So the factors x plus 2 and x plus 3 tell me the solutions. X equals -2 and x equals -3. And I have solved the equation because I have found the x values that make the equation true. All right, let's do another example. I think I can get it into the rest of this page. Let's do the other one. Let's solve x squared minus 4x minus 21 equals 0. So I want to find the x values that make this true. So I want this expression to equal 0. So I want to find the x-intercepts. And when I factor, I'm going to get x plus 3 times x minus 7. And that should equal 0. So if x equals -3 and if x equals 7, if -3 goes in, I'm going to end up with 0. And if 7 goes in, all right, so these correspond to the factors. That's our basic. To solve a quadratic equation, where one side equals 0, and this is important, where one side is 0, just factor the quadratic to find the corresponding solutions. And now we start adding in different ideas, different wrinkles. So let's look at extensions of this idea. My first extension is going to have a factor that isn't just a simple x plus or x minus. And let's suppose it's already factored. And so I want to solve this equation. But remember, solve is to find the x's that make it true. So we want the x's to make the left side 0. The x minus 1 should be fairly obvious. If x equals 1, it all is going to be 0. But the 2x plus 6 is not as obvious. Should x equal 6 or negative 6? Maybe the x should equal a 2 or negative 2. None of those are the way to do it. The way to do it is simply say, if I have 2x plus 6 times something, I want that whole factor to equal 0. So make the whole factor equal 0. So if 2x plus 6 equals 0, I'm going to solve the factor for x. Subtract 6 from both sides. I have 2x equals negative 6. Divide both by 2, and I get x equals negative 3. And that's my other solution. So when you're solving a quadratic expression where one of the terms is not a nice simple x plus or x minus, you just solve that specific term for x, which will give you the other solution. That's one of our extensions. And that came when my expression was already factored. So now let's look at another extension. What if you have a quadratic equation that is not factored and it doesn't have a nice simple x squared? Well, you still are going to solve by factoring. And the first step to factor something where the leading coefficient is not 1 is just to factor out the leading coefficient. 2x squared plus 2 times 2x gives me 4x, minus 2 times 3 gives me negative 6. And then I factor the inside using the box method, and I'm going to find that I have x plus 3 and x minus 1. And now I'm already factored. These are the nice simple x plus and x minus. So my solutions are the corresponding values, x equals negative 3 and x equals positive 1. And I'm done. By the way, you should have noticed, well, maybe you shouldn't have, but I hope that I can point out to you that these are the same solutions that I had in my earlier equation, x equals 1 and x equals negative 3. And here I have x equals 1 and x equals negative 3. And the reason for that is because of that 2 right there. So I just want to point out, watch what happens if I multiply the 2 into my first expression. I'd have 2 times x plus 3 times x minus 1 equals 0. And I'm going to distribute that 2, and I get 2x plus 6 times x minus 1 equals 0. And that is the earlier equation. Two x plus 6 times x minus 1, 2x plus 6 times x minus 1. So I use the same example for both processes just to show you that there are different ways to approach it, or that you might end up with similar questions that you solve in different ways. I like this way. I like factoring out the leading coefficient because then I just get the x plus and the x minus. It makes it super easy. All right, more extensions. What if you have a quadratic expression? Let's see. But it doesn't equal 0. Well, the thing as mathematicians is whenever we solve expressions with quadratics, we want them to equal 0. I don't like that it doesn't. I don't like this. So I'm going to fix it by making the quadratic equal 0. And we've done this sort of thing before. We just haven't done it in a while. To make it equal 0, let's just take 10 away from both sides. And now I have x squared minus 4x minus 60 equals 0. And I'm ready to factor. You should only factor if you equal 0. You can do it otherwise, but it's not going to help you solve an equation. So only factor once the quadratic equals 0. And if you remember this rule, it'll save a lot of mistakes. So let's factor this new one. If I were to use the box method, I should find that it's x plus 10 and x minus 6, because 10 times negative 6 is negative 60, and 10 minus 6 is, let's make that, I did it wrong. Switch the signs, it should be x minus 10 and x plus 6. Because negative 10 times 6 is negative 60, and negative 10 plus 6 is negative 4. And so my corresponding solutions are x equals positive 10 and x equals negative 6. And we can check those in my original equation. And you should always check it in your most original equation. Let's try 10 for x. So that would be 10 squared minus 4 times 10 minus 50, which is 100 minus 40 minus 50, which is 100 minus 90, which is 10. Yep, it works. And the negative 6 would also work. So that's how you solve an equation that does not start equaling 0. You just make it to equal 0. And you can do that even when it looks pretty complicated. Let me show you an example of that. Let's solve 3x squared minus 7x plus 2. And I'm going to have that equal 2x squared minus 3x plus 23. Right, that I'm jumping all the way up to a pretty complicated example, but the key is I've got quadratics and they're not equal to 0. So we're going to make the expression equal 0 by taking the 3x squared minus 7x plus 2, which equals 2x squared minus 3x plus 23, and we're just going to start getting everything over to this side. Let's get the 23 over first. And I have 3x squared minus 7x minus 21 equals 2x squared minus 3x. Let's get that negative 3x canceled out. And so I have 3x squared minus 4x minus 21 equals 2x squared. I'm almost done. let's get the 2x squared over here. And I end up with x squared minus 4x minus 21 equals 0. And now I'm ready to factor because I have a quadratic expression that equals 0. And I built this one specifically to factor the exact same way one of my earlier expressions did, because that made it easier on me. So my corresponding solutions are x equals -3 and x equals 7. Now, if you were to say, here's my original equation, do you think that x equals -3 solves it? I would say, I have no idea. That's complicated. But by doing some algebra to get it to where I can use my factoring tools, I can say with confidence, yes, x equals -3 makes this quadratic equal 0, which is equivalent to my original equation. All right, let's look at a couple of our special cases, right? Our special cases factoring. Let's solve x squared minus 25 equals 0. And we can solve that by factoring. It already equals 0. And then I remember this is an a squared minus b squared, so it must be x minus 5 and x plus 5 equals 0, because it's one of my special cases. I think was my third special case, the difference of squares. By the way, difference of squares comes up a lot in mathematics. It's this idea of symmetry. If we think about what this expression, what this graph looks like, it's going to be perfectly symmetric around the vertical axis. And it crosses, again, symmetrically at -5 and +5. Oh, by the way, those are my solutions. The x minus 5 corresponds to a solution of x equals 5, and the x plus 5 corresponds to a solution of x equals -5. What if we have something kind of like it, but a little different? Let's mix the two ideas that we've talked about. Let's solve x squared minus 17 equals 1. And we notice, aha, not equal to 0. So the first thing I'm going to do is I'm going to get it equal to 0. So, yeah, sure, I don't mind. Not the one I planned, but it'll work. Subtract 1 from both sides, and I get x squared minus 18 equals 0. This is still the difference of squares. It's x minus the square root of 18 times x plus the square root of 18. If that equals 0, then my solutions are x equals the square root of 18 and x equals the negative of the square root of 18. I want to make a note about answering a question. If I say factor x squared plus 2x, let me see, minus 3 equals 0, then you can be done if you write this as x plus 3 times x minus 1 equals 0. But if I say solve, hold on. If I say solve x squared plus 2x minus 3 equals 0, then the first step would be to factor it. But you are not done until you identify the actual solutions, x equals -3 and x equals +1. So factoring and solving are different expectations. If I want you to factor it, you get a stop in the factored form. If I want you to solve it, you have to actually tell me the x values that make it 0. You have to go all the way to this step. Look at another special case. Let's try to solve x squared plus 9 equals 5. And I say, okay, well, that's not going to work. It's not equal to 0. So let's get it equal to 0. So subtract 5 from both sides, and I get x squared plus 4 equals 0. This is our special case that doesn't factor, because it's x squared plus a number. And if it doesn't factor, it means there are no solutions. If I cannot find an x squared that makes this number equal to 0, there are no solutions. And if I can't factor it, there are no x values that would make it equal to 0. Let me show you what that looks like on Desmos. I want x squared plus 4 to equal 0, but remember that would mean that it has to touch the x-axis. It definitely does not touch the x-axis. There are no solutions. The graph never touches the x-axis. Therefore, there are no x-intercepts. Therefore, there are no solutions to the equation x squared plus 4 equals 0. And so our answer if you are asked to solve x squared plus 9 equal 5, our answer is there are no solutions. Let's look at our other special case. Let's look at, let's do 2x squared plus 12x plus 18 equals 0. And the first thing I notice is since there's a 2 there, let's factor out the 2. And I get 2 times x squared plus 6x plus 9 equals 0. And then I notice this has the form x squared plus 2bx plus b squared, because 9 is 3 squared and 6 is 2 times 3. So I could definitely use the box if I want, but I could also recognize this is the special case where it's x plus 3 times x plus 3, which we often write 2 times x plus 3 squared equals 0. And there is a solution, but there's only one. The one solution is x equals -3. There's one factor that shows up twice, but there's only one unique factor, and the corresponding solution is x equals -3. Let's take a look at what that looks like on Desmos. Let's see, 2x squared plus 12x plus 18, which we factored into 2 times x plus 3 times x plus 3. Notice those are the exact same graph. And notice that it touches the x-axis only at one point. There is one x-intercept. Therefore, there is one solution to the quadratic equation. By the way, you noticed I've used Desmos a couple times. You are encouraged to use Desmos to check your answers and or to help you get intuition. Desmos can solve most of these. But I still want you practicing by hand. All right. Let's see if there's anything else. Oh, goodness. Pause. All right, let's take a look at what this looks like. Pause. Okay, let's take a look at what this looks like using Desmos. So we had 2x squared plus 12x plus 18, and we wanted that to equal 0. We factored it into 2 times x plus 3 times x plus 3. These are the same graph. And notice that it touches the x-axis at exactly 1 point. There is one x-intercept, and that means there is one solution to the quadratic equation. And that solution is x equals minus 3. By the way, you've noticed I've used Desmos a couple times to illustrate these ideas. You are encouraged to use Desmos to check your work or to get intuition when trying to solve or when solving equations. That's great. In fact, Desmos can solve most of these equations. It's just looking for the x-intercepts. But I want you to practice solving by hand also. Okay, there's one more kind of specific example that I want to go through. And that's when we have something that looks like, so it's another kind of an extension. Let's solve x squared minus 4x equals 0. And so we might ask, how do we go about factoring x squared minus 4x? The box method would work, but this is kind of a special case for factoring. And we have done this before, but not in this context. And what we do is we notice there's an x in both of these, x times x minus 4 times x, which means we can factor out one of those x's. And we have x times x minus 4. Now, this means there are two solutions. The corresponding solution to x is x equals 0. And the reason for that is if I put 0 in for x, I have 0 times negative 4, which is 0. And then I also have the other solution with the x minus 4 is x equals 4. So it's very common when you see something like x squared minus, or how about plus 7x equals 0, it's very common to say your only solution is x equals minus 7. But you have to think about factoring it, and if you factored, you have x times x plus 7 equals 0, and that x gives you another solution. It means when x equals 0, you also solve it. All right, that wraps it up for this section. Thanks for watching.